Hello friends, in this AV we are going to solve the numericals of the first exercise of the very first chapter of class 9 physics, that is measurements and experimentation. So we come to the very first numerical of exercise 1A. The first question says the wavelength of light of a particular color is 5800 angstrom. Express it in nanometer and meter. So in this AV I have solved the questions beforehand so that we don't have to waste time writing it. So here wavelength is given to us as 5800 angstrom. We have to convert it into nanometers. So we know that 1 nanometer is equal to 10 angstrom. If you bring 10 this side, then 1 angstrom is equal to 1 by 10 nanometer. So if 1 angstrom is this much, 5800 angstrom would be 5800 divided by 10, and this is your answer. Now the second part of the question says we have to convert it into meters. So 1 angstrom is 10 raised to the power minus 10 meters. So therefore 5800 angstrom would be 5800 into 10 raised to the power minus 10 meters. Now you divide it by 1000 so that you can get the point here. So this becomes 10 to the power minus 7. Here 10 to the power minus 10 means 5800 divided by 1 and 10 zeros. So from there 3 will be used to put this point, and that is how from 10 we are left with 7. So we have 10 raised to the power minus 7 means this number is in denominator. Now we go to the second question. It says the size of a bacteria is 1 micron. Find the number of bacteria in 1 meter length. Now for this question we have written here the size of a bacteria is 1 micron. This is given to us. Now from the conversion chart we know that 1 micron is nothing but 10 raised to the power minus 6 meters. So therefore number of particle is equal to total length divided by the size of one bacteria. Total length is 1 meter. This is given in the question. So 1 divided by size of one bacteria is 1 micron, converted in meters is 10 to the power minus 6 meters. So 1 by 10 to the power minus 6 is equal to 10 to the power 6. Now the third question says the distance of a galaxy from Earth is 5.6 into 10 raised to the power 25 meter. Assuming the speed of light to be 3 into 10 raised to the power 8 meter per second, find the time taken by light to travel this distance. In this question they have given us the hint, that is time taken is equal to distance by speed. So for this question we have written the given things. Distance of galaxy is 5.8 into 10 raised to the power 25 meter. Speed of the light is 3 into 10 raised to the power 8 meter per second. So time taken is equal to distance divided by speed. This formula is given in the question itself as a hint. So we just put the values. 5.6 into 10 raised to the power 25 divided by 3 into 10 raised to the power 8. When you divide 5.6 by 3, we get 1.8667. Actually it would be 666 something, into 25 minus 8 is 17. So 10 raised to the power 17 seconds. Now we make a round off and we write it as 1.87 into 10 raised to the power 17 second. Now the next question, question number 4 says the wavelength of light is 589 nanometer. What is its wavelength in angstrom? This is similar to question number 1. So here we just write the given things. We have been provided the wavelength of the light is 589 nanometer. Now we know that 1 nanometer is 10 angstrom. So therefore 589 nanometer would be 589 into 10 angstrom. So this comes to 5890 angstrom. Now we come to question number 5. It says the mass of an oxygen atom is 16 U, that is 16 atomic mass unit, which is known as AMU. Find its mass in kg. Now here we have written the given things. Mass of the oxygen atom is 16 U, which is given in the question. 1 U is 1.66 into 10 raised to the power minus 27 kg. If you check your textbook, you will find this relation in the 1 atomic mass unit section. So the mass of the oxygen in kg would be this multiplied by this. So when we multiply, we find it to be 26.56 into 10 raised to the power minus 27 kg. We just shift the point this side. So from 27 it becomes 26, because minus 27 means this is in denominator. So we are shifting the point, so it becomes 1 less. Next question, question number 6 says it takes 8 minutes for light to reach from sun to the earth's surface. If the speed of light is taken to be 3 into 10 raised to the power 8 meter per second, find the distance from the sun to the earth in kilometers. Now, for this question, we have written the given things. Time taken by light to reach from sun to earth is 8 minutes. Convert it into seconds, because the SI unit of time is seconds. So 8 into 60 is 480 seconds. Now speed of the light is given to us as 3 into 10 raised to the power 8 meter per second. Now using these two, we use the formula distance is equal to speed into time. So speed is 3 into 10 raised to the power 8 multiplied by 480 meter. Now when you multiply these two, 480 into 3, you get 1440, that is 1440 into 10 raised to the power 8 meters. Now when meter is converted into kilometers, we divide it by 1000. So here, if you divide this by 1000, this becomes 1.440, which we have written as 1.44 into 10 raised to the power 8 kilometers. This is the answer. Now coming to the last question, it says the distance of a star from Earth is 8.33 light minutes. What do we mean by this statement? And express the distance in meters. So by the statement that the distance of a star from Earth is 3.88 light minutes, we mean that the light from that star takes 8.33 minutes to reach from that star to the Earth surface. So we have written this, and this is what it means. So here the statement means that the light takes 8.33 minutes to reach the Earth from that star. Now speed of light is 3 into 10 raised to the power 8 meter per second. This is given to us, or 1 light minute is equal to 1.8 into 10 raised to the power 10 meter. Now this you can check from your textbook. I'll just show it to you here. It is given here 1 light minute before the definition of 1 parsec. 1 light minute is 1.8 into 10 raised to the power 10 meters. So either we can use this, or we can use the speed of light. Now and the time is 8.33 light minutes. So if I use this and the time, this speed of light and the time, then I have to multiply it with 60. If not, I will use this, that is 1 light minute. Then I can simply multiply this with the time. So please remember, two ways of doing it. If you use 3 into 10 raised to the power 8 meter per second, then you have to multiply it with 8.33 multiplied by 60. Now if we are not using the speed of light, we are using this 1 light minute, which is this multiplied by 60. So we can simply multiply it with 8.33. So here I have just multiplied both of them. So distance is equal to 8.33 into 10 raised to the power 8.33 into 1.8 into 10 raised to the power 10 meters. Now if you multiply these two, we get 14.994 into 10 raised to the power 10 meters. Now if we shift the point this side, it becomes 10 raised to the power 11 meters. If we make it round off, then we can write it as 1.49, can be written as 1.5 into 10 raised to the power 11 meters. Now that's all in this AV. Soon I'll be uploading the numericals of the third part of this chapter, because the second part of this chapter is regarding vernier caliper and screw gauge, which is only to be discussed as an instrument and how do we take measurement. The numericals are not in syllabus. So that's all. Happy learning. God bless.